Okay, what we're going to have a look at is a way to balance this redox reaction under alkaline conditions. The first stage is to identify which species are oxidized and which are reduced. Well, we may as well start at the beginning. You can see we have nitrogen in the nitrate ion, which has got an oxidation state of 5 plus. And on the right hand side we've got nitrogen and ammonia. The nitrogen's got an oxidation state of 3 minus. Remember, the more electronegative species takes a negative oxidation state. So these there is a redox reaction that has taken place to go from nitrate to ammonia. So let's put these two species down. We'll forget little x's at the moment. Now you'll see here we've got, it's a bit awkward this, because we're allowed to deal with, under alkaline conditions, with water and with OH minus ions. Now clearly water has got one more hydrogen than OH minus. And what we need to do is we need to add hydrogens in on the left hand side here to bind, if you like, with the O3 minus to make water molecules. And so the way to do this is to put waters on the left hand side. So if I copy this, well, I don't copy this equation, I'm going to take a water molecule out here. I'm going to leave the B and I'm just going to wipe that out in a moment. We'll copy this. We're going to add in water molecules. Take the B out for a moment. Now, how many water molecules do we need? Well, we can see that we need to absorb these oxygens here and we need to make them into water molecules. Well, altogether the number of water molecules will be 3 water molecules from these 3, and there'll be 1 water molecule from every one of these. So what we want is we want 3 altogether, and on the right hand side we need 3 OH minuses. So I'm going to copy this OH minus here. Let's put that over here. Now this we should have succeeded here in producing, on the left hand side we've got 6 hydrogens, on the right hand side we've got 6 hydrogens, that's right, but there's still a problem because on the left hand side we've got 6 oxygens as well. So in actual fact what we need to do is we need still more hydrogens from the left hand side. I'm going to put 6 in here, and now this is going to produce all together 6, 12, and now if we put 9 in here, 9 OH minus, that should, how many have we got? We've got 12 hydrogens and we've got 9 oxygens. So this is partially, well, we're on the way to being correct, but there is a slight problem. The slight problem is on the left hand side we've got 1 negative, and on the right hand side we've got 9 negatives. So we need to add in 8 negatives, 8 electrons, 8 E minus, on the left hand side to balance the half equation electronically. Okay, so it's a bit of a tricky one. Now there was a quicker way of doing this, but I don't want to go into that because it isn't as clear. Okay, so fundamentally what we did is we had to keep adding waters in order to absorb the oxygens from the nitrate, and the excess we needed 3 OH in excess to absorb the 3 oxygens here. Alright, there was a bit of trial and error involved, but we can see that 6 water molecules on the left and 9 hydroxide ions on the right did the trick. Okay, so this gives us the one of the 2 half equations. Now the other half equation it's much more simple. We can see on the left hand side we've got aluminium. Let's copy aluminium there. On the right hand side we've got aluminium in this species AlOH4 minus. Now what's the oxidation state of the aluminium? Well, if you work it out, OH is minus, there's 4 minuses, overall there's 1 minus, so Al's 3 plus. Okay, so the change is Al to Al3 plus, it's an oxidation. Right, so how do we get the 4 OH minuses? Well, it's not that difficult in this case. We can just simply add in 4 OH minuses because we're allowed to add OH minuses. Right, so let me take the OH minus here and put it here, 4, and that balances the equation in terms of atoms. but it doesn't balance the equation in terms of electrons. Here on the left hand side there's 4 minuses, on the right hand side there's 1, and so what we need to do is we need to add 3 electrons to the right hand side. 3e minus, and that sorts the equation out, the half equation, electronically and for atoms. Okay, so we've got our 2 half equations now. Then the next step is to equalize the electrons. Now this is quite a tricky one, well, tricky in some respects, but you can see that the simplest factor which 8 and 3 go into is 24. So we need to multiply the first equation here by 3 to make 24, and I'm going to put it in square brackets like this. Alright, just to show that everything is multiplied by 3. And I'm going to need to multiply the second one, put this in square brackets again, by 8. And that will make both of them, the electrons in both, equal to 24. Alright, so now it's a case of multiplying this out carefully. I'm going to put them down, I'm going to put it down here. Oh, one too far. Let's multiply it out, so that's 3NO3, and 3 6s are 18, 18H2O, and 3 8s 24, 24 electrons, and 3, multiply that by 3, multiply this by 3, 27 OH minus. That's a horrible looking half equation, but that's the way it is. And the next one we need to multiply this out as well. We need to multiply out the aluminium half equation. So we've got 8Al, now 8 4s are 32 OH minus, 8 aluminium oxides, and 24 electrons. Right. Now the next step is we must now add our 2 species together. So let's just do a add together here. Add. And this is going to give me, so I'm just going to copy the left hand side of the top one. Now you'll see first of all we've got a 24 electrons on the left hand side in the first equation. Let's block it yellow so you can see it. And we've got 24 electrons on the right hand side of the bottom equation. So when we add them together, these are going to go out. So I'm not going to select them. I'm just going to select whatever else is there first of all. We have 3NO3 plus 18H2O. Plus, on the left hand side here we've got 8Al plus, copy 32 somethings. Look at that, what's happened there? That's 8's gone to a funny, I'm just going to change the font there, I don't know why that's happened. Right, and now we need a little arrow, and the right hand side of the first equation, and the right hand side of the second equation, which is 8Al. Let's add that in there, plus, and we're almost finished now. Now we just have to look to see what we can cancel out. Well, you can see, let's go to the water. Can we cancel water out? No, can't cancel any water out at all. Can't cancel any nitrate ions. But what we can cancel out is we can cancel some of these out. There's 32 OH minuses here, and there's 27 OH minuses here, so we can completely wipe out 27 from the right and 27 from the left. So 27 from the right, 27 from the left leaves us 5, and that's the final balanced equation. So it looks horrible. 3NO3 minus plus 18H2O plus 8Al plus 5OH minus gives 3NH3 plus 8AlOH4 minus is the final balanced redox equation. Now if you want to check it, you would have to count up all of the atoms and make sure that they are correct. Let's take hydrogens. There's 36 hydrogens here, that's a lot, and here there's another 5, that's 41. And here 3 3s are 9, and 8 4s are 32, 32 and 9 is 41. So you can see the atoms look like they're going to balance. Let's count the charges. 3 minuses on the left, 5 minuses on the left, that's 8 minuses on the left, and on the right hand side 8 minuses. So the equation is correct and is balanced for both atoms and charge. It's a horrible looking equation, but just by following the process we get to the correct answer.